Right, so I'm Rajani. I'm a principal engineer at U-Blox, and I have 20 plus experience in software engineering. I started computing since I was a child, and I have just carried on. So computing in COBOL, Fortran, Pascal, DOS, you name it, assembly language. I've been through all of it, and I have. I've been able to learn, and it's a constant learning, clean code. So here I am today going to talk about clean code, but more in a very interactive fashion, because we can all exchange ideas of what we do within our organization and how we can learn from each other. So my first question would be, have you seen or written bad code, and what were the reasons? So I will pass it back on to the audience to actually share. Go ahead.
Oh, hi, nice to meet you, Rajani. My name's Hamda. I'm very new to coding, so I'm on a data engineering bootcamp here in London. So I have a lot of experience of writing very bad code, I think, as I'm still in my infancy. I've only been coding for 6 weeks, but I look back on some code that I'd written 6 weeks ago, and no, a couple of weeks ago, and I had one function that was 100 lines long.
Oh, wow.
And it was just doing a lot of stuff. I think I'd created one broad concept and wanted to just throw everything in there, but then I hadn't learned about testing yet. So then as soon as I learned about testing, I was like, this needs to go in the bin. It's terrible. So I've been frustrated by my own bad code many times.
Excellent. Actually, the first point in getting clean code is being able to spot it. So you're already there, right? You're there halfway through that you are able to spot it. Because I find engineers struggling to find what is wrong with their code, and they think it's good. So, I mean, hats off there. Anybody else would like to share? So let me share my example. Yes, I have written bad code due to time pressure, and it's basically like, let's do it later. Let's focus on the goal. Let's get it done. We try and create a backlog saying, hey, we got to refactor this code and leave it in there. And then, yeah, like I say, Agile, we do add technical backlogs, but yeah, sometimes under pressure, you just can't get everything done. That needs a design, a proper design, and sometimes I just give it some time. It actually helps with my decision making on what I want to do with the design. And have you been slowed down by bad code, anyone? Have you written bad code and that has slowed you down? It has in our instances where we've written bad code, and by the time it was more like fixing, trying to understand, and it takes longer to get there because you're trying to fix issues in the system, and you don't even understand. Like every time you say, I want to know what this function does, you'll be all over the place before you come back to like understanding. So yeah, I have seen, and it's slowed me. Anyone else would like to share about bad code and how it's slowed?
Yeah, I really want to share that I worked it was a big company, but the business unit of it was like a startup. So, and they built everything in Scala, and they rebuilt it from scratch from PHP for a very short time. And they didn't agree even what actually they will use in different departments. So as Scala also didn't have any alignments. So one department use Zero Cats, one department use Akka flows, and everyone used different things. And when I joined, I didn't know even how bad is it. Like you just can't switch to another department and like suggest them a fix because you don't understand what's actually written here. Everything in another paradigm. And also because they were a startup and everything very experimental, they didn't cover anything by code, which we were like, okay, I do not know if I break anything. I just like put another function there. And yeah, it slowed down some features. Some logic was written in so complex functionality in Scala by the person who left the company. So we just couldn't change this class at all. Like we need to figure out how to go through this logic, and we couldn't amend it. So we need always to build a workaround about this object. Yeah, that's very interesting.
That reminded me of one of the code we ported from, the old infrastructure to like a new serverless infrastructure in AWS. And believe it or not, it was written in C#, and you wouldn't dare to touch any parts of the logic. It was like hideous long function, and we were like, it's been running for like 10 years. It should be good. We didn't have any regression tests, of course, which we further, we added eventually. But we were like, okay, we're not going to touch anything. And in fact, any decisions of like, changing the logic, we are like, we go back and say, nope, we're not touching that code. So yeah, I can relate to that. So someone else shared this, put their hands up. Please feel free to share.
It's my time. Yes, I worked in some project where there was an old code base in framework called Kohana, which documentation is half working, half not. And there were variable names like A, B, C, and I didn't understand it, so I dumped all the variables to be able to understand the code.
Excellent. Oh, wow. Yeah. I mean, I think I haven't come across ABC, but it would have been mind blowing if I did, come across ABC. But that's how we all start off, right? I mean, when we start coding, we it's baby steps. Just like babies, you make mistakes before you actually learn and grow and learn from your own mistakes as well. Anybody else before I move on? Okay. Right, talking about the meaningful names, timely presented, A, B, and C. So I think, so one of the things about code, clean code, is that you want it to be readable. And if it is readable, then it's also maintainable, because you know what's going on and you can fix it and you can maintain the code. But if it's not readable, it's the biggest problem about code. Now, meaningful names for functions, variables, whatever, and how you call the variable should explain what they're doing, and thereby you can reduce the amount of comments you will add, right? Because if your variable is defined as A, for example, you need to explain what this variable holds and does. But if you you actually rename the variable to something that actually is self-explanatory, then you don't need comments, because sometimes comments have a way of actually messing up with the readability, because too many comments, you're losing this, too many lines of code, and of course you're losing track and sight of what's required. So there are some of the various the usual thing, put method, just make sure that you have you don't use like encoding, for example, or just don't put it in your words. You're thinking about something and then you just put a variable, but the other person who comes and reads it will not be able to get it. And like, don't use pun, use solution domain names, use problem domain names, so it makes sense. And use pronounceable names as well, like something that like if it's a word that you have to look up Google to understand what that means, then that's also a problem. So just make sure that it is it's readable, and using these function names and method names and class names, it actually is very obvious what you're doing. Then when you've written a class and you've instantiated object, when you do run or do call methods on them, then it is self-explanatory of what you're trying to do at that point, which is really good, really important bit. There are, however, sometimes there are just like your domain names, right? When you come up with domain names, you can't just like figure out what domain name you want to go. There have been instances where I can't decide on a best name. So I wanted to like throw the question back to the audience to see, what do you do to make names meaningful? Do you have any tricks? Do you have anything that you follow to make the classes and the methods more readable and meaningful? Back at you, audience. Anyone? Please feel free to share. Okay. There's I'm assuming there's yeah, okay, Hamda, go on.
I guess, yeah, even if they're a bit long, sometimes it feels like there's sort of several words. I want it to sort of display exactly what I mean when I use it. Like if I wanted to print all the lines of something with the indices, I could be print lines with indices.
Excellent. Yeah. Anybody else?
For me, the trick that I'm trying to not use like of or any other prepositions. And I'm trying to build the name like the most clear, but like you need to use words without prepositions, so and everyone could understand what you mean. That's my trick.
Okay. Right. The next topic is comments. So you can, I mean, I think we've all, there was a phase in engineering where, you know, there was focus on writing comments, and that if your class files had comments, it was a good thing. You know, this is in the last 25 years where it's gone to like having comments is a good thing. And if you see, you can actually have like summaries on top of a function to explain what the function does, their inputs and outputs, and any you know, return values and explanation. I'm not saying that's not bad, but there was if you have run like Visual Studio and get it to you know, run the standard formatting and say, hey, can you compile and pick up, it would basically like pickups that, oh, you for this particular function you haven't like given the summary or explained it, so on and so forth. So there was a time, but I think over the years we've come down to, we've realized that actually commenting is also a bad thing, and that your code has to be your documentation. Literally, if you've written that good readable code, you don't need comments, and hence you know, your code is your comment. So so one of the risks of adding comments is that, you know, your function changes, and we've all seen this, I'm sure, that we all write comments for goodwill, and then the function changes, and then it's always outdated. You can never keep the comments, you know, for me at least, the function summaries in line with what the function does because of the changes. So the little you write, the better it is. Of course, there are reasons why you would you want to add good comments. Use it sparingly and only when it's required. Like say, for example, you want to have a to-do, or you want to specifically mention that something that's not obvious in there, but it's there just to highlight, and you would basically say, hey, but again, it's very sparingly used in like say you want to warn the consequences, don't do this, or so on and so forth in case of test case. And don't include the license information, because I've seen code where you open and then, you know, first, like, I don't know, 50 lines are just the license, and then you carry on. You can automatically like close all of these, but still you can just include a link for the license if you want to put the license information versus putting the whole license in. And license also, like these days, is changing as often, but changes. Then you have to maintain the copyrights and update, and it's too much faff. But if you just send it, give it a link, of course you change it in one place, and then everywhere else it changes. The other one is block comments. You especially do it for like C and C++. You have like a big block comments, and you write in caps. It depends. Like if you're, for example, you're processing bytes or standards, and you put it in there, and then you try and implement it, and that block comments is basically to highlight. But you keep doing that. If you keep putting too many block comments, then when someone is reading it, they'll say, oh, it's another block comment, and ignore it. So use a block comment for really when you want to draw the attention of the reader to understand that this is important. But use it sparingly. Just don't put block comments everywhere. So that's something you'll have to remember. It's good, but only if you use sparingly. So I would like to call upon the audience to say, have you seen instances of bad comments? What is bad comments for you? What does it mean for you? And this whole debate about how much comment you write versus your code being the comment. I'd like to just hear people's experience and just share your experience and thoughts.
Okay, I can start here. So before I read this book, I thought that, well, I realized when I read it that Java documentation that's written for first Java libraries, indeed, a lot of unnecessary comments. And it's the whole magic that you need to write code in that way that you even don't need documentation. Then the reader of your code can understand everything without any tips and comments and anything. That's the magic, and that's the craft.
Yeah, go on.
For me, I would say a red flag is when you're dealing with code where seemingly there's more comments than there is actual lines of code. I'm of the train of thought that your code should be clear enough that people understand what it does. And I do use comments in my process of writing code. But if it's not a summary, then having to write a comment tells me that there's some refactor needed. And I usually try to go over it until I'm in a place where I don't have that. And a trap that I fall into sometime is when I have a method, a class, or a function that's supposed to do, let's say A, and then I find myself doing, B, C, and D as well, because again, they're like little nuggets and things like that. And that can make things a bit confusing, which usually is where the comments are coming from, right? So when that happens, it's like, well, either I need to, update my function or class name so that they take into account the additional stuff that I'm doing, or I need to, take these additional things, have them separate, being separate somewhere, and just, refer to those classes or methods where I need them, and just go from there. Yeah.
Excellent. So that reminded me of, even sometimes when it's just one line and there's a couple of logics, like it's almost like if this condition do that or else this. And sometimes what I do is I even wrap that into a function. A, because it could be used in your test or wherever, but also because it gives you readability, like what that function actually does. If it's not obvious in that logic, then I just if it's a sort of a little more complicated logic, then I just put it as a function and say, this is a function that does that and returns something. And then because by introducing the function there, the code becomes a bit more readable, because you come down instead of like using your code to like say, oh, what detail is going on, I abstract the detail off and then just put a function to say, I'm doing, like so and so, and then it's obvious to the reader to do so and so. And if they wanted to get into the details of it, of course, it's below their it's below the function, the callee function, and then they can always go and see. So that's that's something that jogged my memory. Others, feel free to share. I know the two of you wanted to share as well.
Hey, maybe Lula?
Yes, like about comments, I don't do it now, but in the past when I was a junior dev and also IDE code highlighting wasn't as good as it is now, I was guilty of leaving a lot of closing brace comments when, for example, I did a 2-11-3 nesting loops and then in the end of each loop on the closing brace, I explained what happens in this specific loop. And of course, I was sometimes guilty by changing what is happening in the loop, but forgetting to update the comment as expected. This is my story.
But it, like I said, we all started like that, and I think there's also like there was a culture of commenting, which you could see from the tools, but then with with Agile coming in place, I think we've moved away with it. And like you said, the classic case is where we have end loop. And sometimes I find it easier before starting to code to write like a comment, okay, this is what I'm going to do, this is what I'm going to do next, and this is what I'm going to do next. And the comment still remains, even though, but if you've written good code, I sometimes find that these comments are obsolete. So then I start taking them out of my things, because then it starts eating into the readability as well. So there's something, we will have to bear in mind. Someone else would like to share? Yeah, Sumaya, go for it.
Okay. Yeah, I'm just going to say, like, especially as a junior developer, I think it really helps to have some sort of comments there. Just like Lula said, she used to explain everything. When I was working as a junior developer, it was quite difficult for me to read legacy code, because some of the the mid and the senior developers never commented the code. So I had to research line by line exactly what was going on, because I was like, I've never done VB script before, and it was just a huge conundrum. So yeah, I do think to an extent I would say comments do help. And yeah, just explain it.
Yeah, and probably comments are, I mean, sometimes comments are good, it's not like you don't need to have comments, but sometimes comment could just indicate how badly written it is as well. So maybe the legacy code is slightly badly written, but each to themselves, see what works, as long as what you're intending to make it readable, so the code is readable. So maybe refactoring the code to make it readable is another way of rather than just adding comments to make it improve the code quality. So functions, this is quite tricky, really. And I say tricky, so we all have done this error where basically we create functions and this function does X, Y, Z. And I think Maximilian actually mentioned that I have a function, but then it like function A, but it does B and C. and then you end up having a function, whether you want to include B and C in it, or do you want to just create, other functions for B and C. So the best possible, clean function is, rather than bunch everything in one function, a function should be small, should just do one thing, and one level of abstraction per function. Try and like for me, this is something I have learned over the years, is that if I spot ifs and a lot of ifs and switch statements and case statements, it just means you can design, you can refactor the code to make you can apply a design pattern there and get it working. So just be aware of excessive use of the switch statements, and use descriptive names, make sure your function arguments also clearly say what it takes and what it returns. Prefer exceptions to returning error codes. So do you want to, do you want to throw an exception, or do you want to return error codes? And I think this one is a bit like, I can't decide, because there are times where I'd want to throw an exception, but most of the times it depends on the whole server. I would want to return an error code, because the exception handling is expensive in terms of code. It depends on the kind of code you're writing. So that is a give and take, but exceptions are good. Like, prefer exceptions over error codes, because sometimes you swallow, you might not be able to get the context, so on and so forth. So make sure that you're throwing the right exceptions at the right places. But then again, it's application dependent. Someone can, I'll invite the audience to share your exception experience on whether you prefer exceptions or returning error codes. But before that, I'll just say that avoid duplicate code, and if you write a function correctly, you will have no side effects of running this function. I saw a piece of code that was being invoked, but was setting some global variable somewhere, and had this side effect to that function, which did, again, as a consequence of doing more. And it was linked to the database. And it was so funny how much the developers spent time understanding what is happening, why is the system erroring, and it just becomes really messy. So just be mindful of how you write, make sure there's no side effects, or you run this function, this happens, right? And that functionality should be just one functionality, and that absolutely just this, not something else. So if you can tell me, if someone can share whether you're an exception person or you're error code person and why, that would be good. It is also probably the language you use and your application you're developing, but it'll be really interesting to know from the audience which way you sway and why. Yeah, go for it.
Yeah. Okay, when you go through the interview, my tip is to use exceptions, because when you coding challenge for the interview, it's very small system that you can code for 45 minutes probably. So the nice perk and advice, use exceptions. Now, in production system, I think we use then both, because we always push exceptions, but we also have good handlers with exceptions. So we wrap up code in this exception, like an error code. So we are doing them both. So we always push exception. And also in this book, it was for me it was very important for me to read that even Java developers who designed the language, they admit that checked exception was experiment that lets them allow to know that there is checked exception. And they then at the end agreed that it's better to use unchecked exception. So you just fail the whole program. And for example, in Scala, you don't have checked exception at all. I don't know about Kotlin. And under the hood, it's the whole Java that actually they have this checked exception still. But yeah, this was very important topic for me, like use exception or use quad or use checked or use unchecked. And that's my answer. So we actually throw both of them, exception and quad. And then we have handlers. So at the end, even from a low level layer of application, it go up, 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 and to the user, if there is a code that actually can be an error to show the user in mobile application, then we have this code hidden in this exception that started in the low level.
Yeah, anyone else? Well, your organization has a preference about exceptions and error codes. I'd like to hear more. As someone who sways towards the error codes in particular, that'll be also nice to hear.
I am more on the throwing exceptions because in my work, I'll build a lot of design and build a lot of APIs.
Mm-hmm.
So when something goes wrong, it's usually partially, sometimes it can be because of the data that was received.
Mm-hmm.
So the throwing exception allows me to, I guess, let people on the other side know what's wrong so that they can potentially troubleshoot and make an adjustment, any necessary adjustments on their side if needed.
Yeah. And I think it depends, like if you're writing security code and you don't want people to know what is going on in your system, then that's another reason why you would obfuscate and, just say error code, and you probably not even, give a message. But yeah, it's debatable. But yeah, that's sometimes where you actually won't throw exceptions. Anybody else before I move on? Okay, 3, 2, 1. Formatting. This I almost have an OCD for formatting. Like when I see extra lines, I can see my OCD coming on. Well, it'll be interesting to see what how others feel about it, and how what organizations do. What is your what is your standards? What is your code formatting rules? I'd love to hear. So feel free to share. Actually, we'll start with what your organizations do on formatting. Like what is the length of your class? Yeah, the use of white spaces, length of your line. Yeah, what is the length of your local variables? I know I know an employee of Twitter was sharing, and I felt it was sort of it was good to know actually from Twitter how they do and what standards they have and how they follow the standards to the T, including variable name and how they define it. Irina, go for it.
Yeah, I'm not sure that we have right now exactly preferences that do not allow me to write code with particular lengths, for example. I can, first of all, I'm really happy that right now it's a lot of environments that allow you to make these properties. So the whole like IntelliJ check if everything wrapped correctly. Again, when I worked with Scala, it was very cool when they started to apply at least schemes for all code, because like there are no no established culture and you can write anything in any way. But at some point they started at least to align everything with these schemes applied in IntelliGD. So that was very nice. And with scheme word, they can check for you if you didn't make a mistake. And recently we had a problem like for test classes, they slowed CI/CD because some methods they have too long names in tests, in functional tests. When we're trying to describe the whole behavior of the system, you can write too wordy the name of the test, and that slows CI/CD. And yeah, that's amazing how it can affect actually system. That's everything that I wanted to share.
Thank you, Irina. Anyone else? Yeah, go for it.
I will probably have problems with that because when I write tests, they have very, very long names.
And does your company actually have a standard at all? Do they have a standard in place, or
Now we have some new tool that fixes some small mistakes, like sometimes I forget that we have to put a new line before return, and now it's automated, so I don't make this mistake.
Good. Is this a readily available tool or a homegrown tool? So something you guys have created?
It's an established tool, but probably somebody tweaked with the rules.
Okay. What's the name of the tool? Angelica, do you know the name of the tool?
I think it's PHP Fixer.
Okay. Right. So first thing, I think formatting is basically, it's a way of communication. So where you put your instance variables at the top or the bottom will mean that the person who is coming and is reading your code will know where to look for it, because there are certain standards where they say, okay, you put all your member variables at the bottom, or your instance variables at the top. So it's almost like communicating how you do it, and having a general guideline towards this is what I want to do is good. One of the important things I want to say is basically the affinity of the logic, right? So always try and make sure, think of it like it's a newspaper. So when you come and look at the newspaper, you have a headline, right? And then you read it, and then you go into the details of it. So if you visualize your class as a paper, it's giving you all the high level details at a glance, and then the details of the implementation later, that will be the best thing. And usually the callee function is at the first, because then when you read that function, then okay, this is the function, and you see various functions, and it's subsequently below the caller function. So these things really help readability, rather than go and hunt for it throughout the line. So I think that is good. Of course, in the indentation, how many 3, 4, you can argue till the cows go home, but yeah, whatever it is your preferred and your IDE uses it, that's good. Yeah, what else? Of course, this formatting style is just not like you come up with this formatting style and then say, hey, everyone, just follow it. Basically, if you sit down with your team and say, hey, let's follow this thing, and then it becomes like your guide, then everyone is motivated to actually follow it, and you will not have issues. And sometimes like use of underscores versus the not of underscores. You can tell which programmer has written the code based on whether they've used underscores or not, for example. So you can try and eliminate. And if someone looks at your code, they should feel like, okay, it gives companies. So like say someone came and looked at the code, like it gives someone external came and looked at the code, it gives them confidence by just looking at this clean code that they can trust you. So it's that they can trust whatever product you build is also of good quality, and you know, it has that huge impact by actually writing, you know, something very trivial like this doesn't really matter in terms of compilation, but it is like the essence of communication in that sense, not only within the team, but also externally. When someone looked at it and they see clean code, they have high opinions that whatever product you're going to build will have quality, because quality leaks in code as well. The other aspect of clean code is objects and data structures. This is a very interesting question, and there will be more slides coming on top of this about data abstraction. So make sure that we are not, for every property is basically you're not adding getters and setters and exposing it. Only expose the information you want, because anyone who's using this class then has only limited view of, right, here are the, you know, the functions and the members I'm going to use to operate on, rather than all the getters and setters, which may confuse them, and actually sharing information may be more confusing to the user of the code. Sometimes what you may want to do is basically this is called the law of Demeter, where you don't want to expose the internals, and you want to make sure that instead of giving like I don't know, like we're talking about how much fuel is left in the car. So instead of giving the tank and this and that, you may just give expose a function to say %. Then it reduces the complexity at their end and how they calculate it, and basically just give one method rather than exposing various variables of the nitty-gritty details of it. So you think about you know, what is that they want, and tackle and abstract everything else, and don't expose all of the getters and setters for that. And it's easily done, as you like I said, you know, if we have very less time, you're just like literally, okay, let's get something working, and then the code stays forever. The the other aspect is about data structures and objects. So you can look at object as something that you can operate on, has functionality, whereas data and data structures is almost like a way to expose the data, right, and has no meaningful function. So that is the difference between a data and an object. So usually data structures, you've used it in procedural language, I'm sure you know, and you use data structures there, and it's easy to add new functions to these data structures without changing the existing data structures. But whereas in object-oriented programming, if you had objects, then it's easy to you know, add new classes without changing existing functions. So the existing functions are there, and you know, you can just add new classes on that works on this in terms of O. But and also the inverse is true, where for procedural code it makes it hard to add new data structures, because all functions relies on this data structure change, whereas in OO it's hard to new functions, because then when you add a new function, then and the, you know, the classes that use that will have to change, right? So so that's the slight distinction between, you know, a data and an object. Although object has information in it, you know, data structures are different and procedural. I mean, that's what I'm driving here. And also there's this data transfer objects, which is like the, you know, data structure and object. It is an object but stores only data. So this is why you needed to understand between data structure and object. So these are actually data objects, right, that hold only data and have no functions on them in OO. And usually you need these data transfer objects. So say, for example, you are, you know, trying to get the database object, right? You're getting the data from the thing, and you want to convert it to an object, which then the rest of the function uses. So these are examples of a DTO. So one question to the audience, how often do you use protected? So one of the things you need to think about is, why have you made this class protected? So that will make you think about your abstraction. So there's very few places where I've had to use you know, protected. So I called the audience to actually see when they use protected, and yeah, and in what scenarios. I'd be just curious to hear. Anyone feel free to start. Come on, coders. Yeah.
Okay, I don't remember about protected class. Indeed, like a class, sometimes a function, because you do not expose this function only for children, but for class, actually, I don't remember. For functions, yeah, because you want only children will be able to override this function, so no one else. I also want to add interesting thing about data transfer object. It's very important to keep them clean as they transfer data, but there are small like exception for finite machine state pattern when you have states. So you can add small logic in this transfer object, which state should follow before the actual state. It's like you still build objects, but there are small checks as well. So, and your data object now like control all these states. It's also like pattern state in object-oriented programming. So that's also interesting thing about that object. They still can validate and verify themselves. Still, they only have data.
I have a few more slides on these, which is very interesting. Hamda, go for it.
I actually had a question. I think people were mentioning that they don't really use any protected classes or anything like that. Are there any instances where that would be a benefit?
Irina just said that if you wanted to expose various like functionality only to your only to the child class in terms of,
yeah,
then you would use
because only they can modify. Oh yeah, sorry, I must have misunderstood.
Yeah,
thank you.
Sometimes in the past there are some functionality which I don't want to expose to the public, but I want it only exposed to for a test, right? So in that case, I have had to use protected, so the test can actually use it, but no one else can see it. Yeah, so I've had to do that. That's my
yeah, that makes a lot of sense. Thank you both.
Anybody else?
Hi Rajni, Namrata this side.
Yeah.
So I work at Oracle. So first thing I would say, like protected classes I didn't use earlier, but yeah, protected method definitely, just to keep my code clean. I mean, if I'm working on particular API and I need to perform kind of calculations, and that's kind of separate thing, right? So for that purpose, I create one protected method, I would say, and then I'm calling in my public method, I would say. So that in that way, like we are keeping information segregated, right? And code will look kind of clean. And yeah, for formatting, yeah, definitely. So earlier I was working in different organization. There we were not paying much attention. But now since I started working at Oracle, they are very particular about it. I mean, how you are defining variables at the time of Aura review, they will particularly like pay attention how you have defined it and what kind of name you have given. I mean, I got comments on variables, not the like how I have written the code and everything. So yeah, and the OCD thing you have said, definitely. I mean, I get like very hyper if I am not seeing proper in a like proper format, because let's suppose we have so many if and else conditions. So if you are following formatting things, so definitely it would be very easy to understand what exactly going on and what all conditions we have inside, right? So yeah, that's from my side. Thank you.
Yeah, thank you, Namrata, for sharing that. And yeah, hats off for Oracle for for doing good key code.
Yeah.
Yeah. Anybody else?
Oh, good.
Okay. We'll move on. Error handling. We were talking about error handling. So like we actually sort of briefly spoke about whether we error handle or not. And what, you know, this is like a general guideline that you rather use exceptions than return codes. You always write a try catch finally statement first before you write anything else, because you don't want like exceptions to be thrown out and you know, causing your systems to break down. And also the unchecked exceptions, you know, unhandled exceptions, make sure it's a lesson for me, the unhandled exceptions. So once, so this is I think several years ago, maybe 10 years ago, we were using IIS for running an exception, and there were try catch blocks wherever, but there was an unhandled exception that popped, and we had even caught the unhandled exception, but the logging line that handled the unhandled exception had an error, and it bombed out of that, and it became a, you know, unhandled exception due to it, despite having it. So I've learned from that every time I've written this unhandled exception, to make sure that there's no exceptions being thrown there, because then the point is lost. And thankfully for IIS, it has a way of dumping this exception as a, you know, a text file, which we could figure out. But yeah, some of the how exception handling is very, very important. And of course, when you are throwing exceptions, you can provide, you know, to the the callee the extra context, and you have like, okay, in this scenario, the exception failed when I was trying to do this, the exception failed, so they have some more information to go on rather than just like an exception. So that's a good I definitely say, if you want to debug code, especially the random ones, it is a useful thing to have, just add more information. And yeah, define exception classes in terms of the caller's need, whatever is based, you know, it's almost like sometimes if you're going down the line of implementing exceptions, it's almost a little like an interface, right? So basically you say, okay, these are the exceptions, and you know, this is possibly and I'm sure that all the standard functions you use, you already know what exceptions are there. So when I'm invoking a function, which is you know, in an SDK, you know, provided by, I use C# in say Visual Studio, then I look at the list of exceptions I can possibly throw. And for me, that's like, you know, like understanding of what can go wrong with the system, and gives me more context of what I need to handle and what I should do and what I shouldn't do, which is very useful. So yeah, definition of exception classes is definitely a good thing in that sense, and define the normal flow, you know, how it goes, so on and so forth, and you know, if there are exceptions, you know, raise it. Don't return nulls and don't pass null. So there are occasions, because in C# you have nullable objects. We do sometimes use nulls as a way of you know, saying, as a way of if it's a Boolean and it's a nullable thing, then it's rather than it being true or false, we use a null as giving a third state for us to say something, it's something went really wrong. So yeah, it doesn't mean don't return null, as in it doesn't mean you have to like 100% consistently not return null. If there are good cases for you to return null, please use it, but refrain from using null. And again, for the same reason that if a null is passed, you have to in your code write if null then this, if null then this, there'll be a lot of checks and it gets in the way of readability. And if you never return null, then you can confidently if it's always instantiated, that you don't have to null check, and there could be readability. But again, this is debatable whether whether you don't want to check for null, how confident you are that the code doesn't return a null is the biggest question, and depends on the context. And those don't pass null, of course. So what we normally do is in the functions, we make sure we always have null checks when the object is passed. However, if it like I say, it depends on the scenario, who's calling this function. If it's someone external, you can't have no control. So if your functions handle null checks, then it's great. It's a sign of clean code, because you never know what scenario, how they use it, and you will run into issues. So don't pass null, of course, but here it means don't send in nulls as a way of handling things in the function, saying, oh, this is null, then do this. If it's not null, then do that. So try and refrain from using, passing nulls around in general. So I would like to call on the audience to share your stories of where you had to use null, or do you use null most of the time rather than a return value, or your stories on the null, or anything you would like to share about error handling and thereof not having error and handling. Like I just shared the experience of, despite catching all the errors, our code still bombed. So any experience, I would love to hear. Yeah, go for it.
Okay, I will start. So in Java, well, they have this nulls, which is $1 billion mistake. And then they implemented several libraries, which like you connect with library, you have annotation, non-null, null checker, and etc. And I think it's cool to use them. Also, I think frameworks like Spring, they also inject a lot of validation for nulls. Personally, in my company, they run their own frameworks, so they build their libraries, and we have static methods to check if there is no null. But our culture, almost in every method, you validate your arguments, because there are no guarantees that someone will invoke your public API, public method with null arguments. So we check them every time. It's the rule in Java. If you build public API, there are arguments. There are no guarantees that there will be no nulls. Anyone can invoke it with null at some day. Yeah. So that's my story.
Thank you, Irina. Anybody else? I may not be able to see that you raised your hand, so feel free to start speaking if no one else has raised their hand, please. Okay,
I also want to share one more thing. I once on one Java conference, I saw that there was a talk how to implement the tool that will allow you to change null pointer exception, because the worst thing about null pointer exception, you don't know which argument exactly was null. You just know that it was null, but no hints what exactly was null. Was it name or first name or second name, who exactly was null. So there was a topic how to change custom Java except like it's a low-level Java exception. So that will be smarter null pointer exception.
Yeah, and this is where they're trying to provide more context with the exceptions, you know, if it happens, because just knowing something went wrong is no is not good enough. Yeah. Okay. Moving on. Boundaries. Okay. I'm sure all of us have actually used third-party code. I mean, I for certainly use third party, even if it's not like you know, different an organization. It could be like different the divisions, because you know they're expert something, and then we get the code as you know, a C library, and then we just run it in our code for doing certain things. And also sometimes because if one division has implemented some, you know, standard protocol paths or something like that, then you because that's validated and tested, rather than you write your own protocol parser, it may be best to use the one that actually, because I work in embedded systems, the one that's used in firmware. If you use the same one in server, and you won't go wrong. So there are some, you know, certain reasons why you'd use this, you know, third-party code and libraries. So basically, in general, it's about having these, you know, knowing about these boundaries between the third-party code and understanding, and it depends on how much documentation you have, so on and so forth. You want to use it. You use it in the way it is meant to be, and yeah, just you know, I have some tests to check whenever, like if you're getting these libraries, have some tests to make sure that your library, when you integrate it and you're getting versions of that you know, it is working as it should. And if there are changes in the interface, keep your tests updated, so on and so forth. So and as always, I've always found it challenging, even like, I don't know, 5th, 6th iteration, it's always like there's something that when we get it, like porting it is a you know, like integration, always there's some hiccup, until such time where then it's effortless, because there's less changes and there's less implication. So I'd like to hear people where you've used third-party code, what sort of challenges you faced, and anything else you would add to how you use third-party code.
Okay. So I used it a lot because I worked, in those startup with Scala, basically everything as libraries, which is a third-party code, and a lot of experimental libraries. More interesting example, in my previous company, I had to write integration with Kafka and Solr, and I found that there are very powerful flows, Akka flows, and I asked, can I just use them, because it's open source, so I want to try, and it's really easy to use it. Like, if you know about back pressure, they handle it under the hood, and it's like you need to write a lot of code if you want to handle it by yourself. But these libraries, they just cope with back pressure. They already have all these necessary tools to allow to slow down consumer if there are too many messages. And I would say it was quite amazing experience, because it's literally several lines of code instead of a big whole logic that I had to implement otherwise. And at the same time, I didn't know about the culture of functional tests. So now I a bit regret that I didn't cover it with smart functional tests. Instead of it, I put only unit tests, and I put it in a test environment, and then I found several bugs that like I could actually cover it. So yeah, that's the challenge. Like you also need to provide very powerful functional tests.
And sometimes it's better to use off-the-shelf solutions rather than reinvent the wheel for. I mean, we all know. Like I just mentioned, it's best, if there is, it's already tested, why not? Anybody else before I move on? Okay, unit tests. I think I must admit that I am not great at writing unit tests, although, we follow Agile, we have the definition of done. It's almost like an afterthought, except for some occasions where you really, the test-driven development, we keep thinking about, we should probably introduce test-driven development and start. And also there's sometimes we have done this, we've gone through iterations of a test as well and tried to clean it, but in time pressure, I think the tests always suffer. But if the tests suffer, then it's it is a problem, because the things you want to do with your test is you want to make it fast, because if it's not fast, people are not going to run it. You're not going to run it, so you want to make it fast. You also want to make it that it's independent, that it's a unit test, it has to be independent and not related to other things, so one failure doesn't break your unit test. You want to make sure it's repeatable, that if you can run that unit test consistently, and you because if it's not consistent and keeps failing, and even if the actual logic fail, you'll be like, is that problem, and then you just ignore it, which is which tends to happen. You also want to make sure the test is self-validating. The test, is very, says exactly what has failed, and it tests itself like a search. You could use a search to flag any issues. And also time. The timeliness of the test also matters. You don't want to write tests as an afterthought, but you want to have tests sooner. And because if you wrote the test later, you always don't design for testability. And I have run into this problem several times, that if you test as an afterthought, the design of your system and your testability always suffers, more often than not. If you got lucky, then it's fine. But there are times where I'm like, okay, because to make it testable, now I have to change things in a certain way. So also you want to keep the test code clean, because like say introducing new features, if you're saying that the test is not, you can't build on these tests, it's going to become the bane of your life, in the sense every time you did introduce some changing these tests, if they were not written clean, will take ages, and your whole agile sprint cycle is going to take long. So focus on having these tests, and we've had this as well, and we've refactored our tests iteratively to bring it in a state where it is clean. And also try and put one assert per test. Don't write a test and test many conditions. Split that test into many things. So if it fails, you know exactly why it failed as well. It's that. And for test-driven development, there are there are 3 laws of test-driven development. You don't write production code until you return a failing unit test. So you write a test first, and then you write your production test. When your unit test is failing, then okay. And this actually will make sure that when you write the code, that it's testable already. And also, you may not write more of a unit test than is sufficient to fail, and not compiling is failing. So you don't want to write. You want to only write enough for what you have, right? And you want to think through your tests. You want to think through how you want to use your system first while you unit tests, and then write your code. And you may not write more production code that is sufficient to pass the currently failing tests, right? So it says focus on fixing the test. don't write more code if your tests are still failing. First, fix the code so your unit tests pass. That's what it is. In all, it's saying don't write production code that you don't have unit tests for. Make sure you have unit tests, got full coverage. Not full coverage. Full coverage is very ideal, but whatever scenarios you want to test, you can go a bit overboard on the unit test. But it depends on what distance. Sometimes writing tests that do not really add value, you need to think about these tests as well. And like say if a function took an integer, you don't want to iterate through all the integers. You want to do some edge cases and a normal case. You don't want to iterate through all the values, for example. So just try and see if these unit tests add value, and add a lot of unit tests will add value in that sense. So my question back to the audience is, how do you manage to keep your tests clean? I mean, we've had to consciously work on this because we were beginning to feel that every update of the test is like, oh my God, this is getting out of hand. And how do you manage to keep tests clean? Do you actually, how are your tests? Are your tests clean as well? Or like when we initially started off, our tests were always, maybe we couldn't, it was good code, but it wasn't clean code. Yeah. So feel free to share. Yeah, Irina, go for it.
Yeah. So when I started my first job, it was a company. There was a new platform, and people who built this platform, they didn't provide tools. So we weren't able to build our tests because it was too many things to mock. And then I joined this startup, so they also didn't cover anything by tests. And it's something that you can't really, it's very difficult to start to introduce it when it's already a lot of things built. So it's something that should be there from the scratch. It's the most important thing when you start to build a new platform. It's important to start with tests as well. I would say that starting with tests even before you write logic, it's like a shift in your mind. It's hard. And I right now built a new project, and we already built a lot of frameworks that can allow to start with tests even before you write logic. So right now I go exactly in this way. I first write tests, and then I write logic. And I noticed that it makes you do not feel like, okay, now I built logic, it worked. I don't want to write tests. I'm lazy to write tests. It's true, it's always when you already built a logic, you don't want to write tests for it. I knew that it works. I say here, it will work. My honest word, it will work. But the truth is that is only even the one person didn't cover something with test. Another more junior person will come to this project, will see that, okay, there already that some methods which are not covered, I will just add new one. And even they want to change your class, and if they see that there is no test, like I do always, is there some legacy code and it didn't cover test, and I add new method, and I just okay, but I'm not going to create the whole test class for all these 15 methods that were there before, so my new method will not be covered by test as well. And I know that it's legacy, and I say okay, we will shift from it one day. So, but that's the point. It's very hard to start there, and it's good if company introduces culture, like in my company, and also my teammates taught me they write perfect tests, and I learned a lot from them. So now I'm trying to build my app really testable, really safe, and that's it. And it's not coming from the first day, that's true.
Excellent. Yeah, so and one of the advantages of having these tests is you can iteratively refactor your code, and so it's clean code doesn't start from day one, right? You iterate over your code until you think it's clean. And you don't, so writing tests is like the fundamental thing of actually having clean code, because you're refactoring. You don't want to, you want to make sure that you haven't broken anything, and refactoring really helps it helps refactoring and towards clean code, and that's why unit test is a topic here. Anybody else? Hamda, you had raised your hand?
Yeah, so I guess just bouncing off of what Irina was saying, I guess I started off writing the logic and then trying to write tests, but it was very difficult. So switching to the test-driven development, it was definitely a mindset shift. I think, it was nice to know that your logic definitely works once you do that, but then it's very difficult as you progress to keep making those unit tests before writing any logic, and I struggled a lot to meet deadlines doing that way. So while I start off very good, and then I would just feel like, oh, this is taking too long, I'm not going to meet the deadline, so I just start writing the production code instead. So I was wondering, like, how do you manage your scheduling, or how do you like make sure you have enough time to ensure that you continue with like the TDD method?
Yeah, so we so in our case, we make sure it's a part of our definition of done. So even if you haven't written tests, the task is not done, the ticket is not done, right? And your backlog is not, your PBI is not done. So we have it as part of a definition of done. So, and hence you actually always have tests, no matter what. Otherwise, even if your code is ready, we will, it's not put to done. So that's how we manage to keep on top of the test. I'm sure others can give you better ideas. Anybody else who would like to answer Hamda's question? How do you keep when you have a tight deadline, how do you make sure your unit tests are your full income it's complete and clean?
Hey, hi, Rajani.
Hi,
Yeah, so I would say like this is kind of learning I had because of previous project I worked in, and test cases are very important, I would say, for junior developer, if they know, because what happens when you start brainstorming around like test cases and what all scenarios possible, then definitely there would be some kind of limitation you'll come around there. So I remember we developed complete screen, and that was kind of navigation between 3 screens. So like after doing complete development, and when we started moving into QA, then we found like we missed one scenario test case, I would say, and later we had to change the design because it was because of limitation. We didn't have that kind of configuration from the API side, and we were not getting a response. So we needed to convey the same thing to customer, and again the same thing started, like now we are going to modify screen design. We will have to include this because of the limitations. So and how we handle this. So I believe like being as a developer and manager, this would be kind of mutual understanding that maybe things looks very easy initially, right? It looks like a very easy screen, and we have only like very small functionality. But once you start giving time on it, and you actually putting efforts in test cases, then you realize how complex things can be. So being in IT for 6 years, I would say like nothing is very easy, it seems. So once you get depth into and start working around test cases, then only we'll get to know, okay, how complex it is. So that's how we manage. And I have taken this as kind of learning, I would say. Like I always put effort in unit tests first and then development, because initially it looks like boring thing, but definitely it saves a lot of time and effort.
Thank you. And that reminds me that you could probably buffer if it's the first time you're writing your tests, then you probably add some buffer to your so your time taken. Of course, you include the time it takes to code, but just give a little bit of buffer also in terms of effort. So
Right.
you can actually complete it as well. I'm just thinking through what else I would do if I had that cycle. That's what I would do. Just buffer a bit more if the tests do not exist, and of course, if the test exists, yeah, a little less because you're just adding to it.
Very true, because once we get the task, we just analyze, okay, these are the things we need to do, and we give estimation based on that, right? But we should always keep buffer because it saves a life, I would say, in that term. So yeah, we have at least one chance to fix things. Yeah, so yeah, definitely buffer is a thing.
Yeah, and alhamdulillah, there's no shame in saying, hey, we couldn't finish it in this sprint. We need more time, and create, if you can create backlog items, more extra tickets to say, hey, shouldn't be forgotten, this needs doing, and make sure that it is there and that you pull it in your next thing and you do it. So make sure that task is also not forgotten. Of course, it's all context and scenario dependent, but different organizations take different approach. But make sure that there is a backlog item so it's not forgotten. Right, okay. We all know that when you write classes, so one part of clean code is writing classes, and there is you want to keep the class as short, as small as possible. It has to have single responsibility, and there should be only one reason to change, like oh, this one. So it basically, if it's one single responsibility, there's only one reason for you to change that class. If something changed about that class, and organizing for change. So try and keep your classes that you keep it open for extension. That is, actually you can extend that class. Also use the dependency inversion principle, which means think about the dependency inversion principle is that you are dependent on the abstractions, but not the concrete details. So say, for example, someone is using, if you have the interfaces, right? So if you implemented interfaces, that is your abstraction, and the your class is dependent on these interfaces, which is defined, and your implementations could change in terms of concrete classes. So always, in that sense, interfaces for abstraction, and try and keep your classes interface based, and your different concrete classes implement based on the interfaces. Have you that occasionally I have found that I find it very hard to organize classes. It's not very rarely where I do write a lot of code, but there are some occasions when I just come and think about, I sit there thinking, you know what, actually it doesn't sit well here. It's so trivial, it can't be a part of a class, and how I organize it. At that point, I know that I need to refactor this class. So I come back again, in the next iteration, I try and then organize the class. And I think just giving a break in your head, sort of when you come back at it and look at it with fresh pair of eyes, it helps me organize the class better than I would have, and when I'm feeling stuck, that's what I do. I would like to hear how you guys, if you find it difficult to organize classes, and what instances there are, if you have anything to share. I take it. Okay, Irina, go for it.
Okay, when I only started to work, I think I procrastinated a lot trying to understand how to organize refactoring and think, okay, now it should be in another way. Right now, it's much more like organization of classes on packages level, on models level, a lot of modularization between logic, and also like the logic should be very like clear by domain, like is it database domain, and only something facilitate between database. And if it's a real logic, like maybe there are some patterns and some services, and I think that helps. And also it helps to know all these popular patterns like object-oriented oriented patterns. So you can follow with them. And when you share with another colleague who also aware about these patterns, they can quicker understand what exactly you meant, because like you implemented this pattern actually.
Yeah, and usually, I mean, I always find that there's a design pattern lurking there. When you look at your class and you're actually thinking this is not, there's something about it that's not right, there's always a design pattern that you can apply to solve these problems. Anybody else? Otherwise, I'm going to move on. Yeah, right. So this is a very hot topic, right? So when you are like a junior developer, you talk about code and all that. But then as you're building experience, you start thinking about your systems as a whole and how you build your system, and you think about the design patterns and so on and so forth. It's yeah, and at this point exactly you would have learned about design patterns, how to implement. So one of the things is about how you build your systems is you want to construct a system in such a way that you want to separate the concerns, right? So you don't want your main to do like everything, including the instantiation of an object. You want to make sure that your main basically is just invoke stuff, and your application, the instantiation of the variables, right, which object to create is left as another another class or another pattern to solve. So you can use dependency injections. So say for example, if the type is this, then invoke this object. You can also create factories, which is like a glorified dependency injection, where you can look at your XML, your config files. You have config files, and you look at your config files, and based on it, you know which one. And I think the dependency injection factories are really good, or also implementing test code. So if you have a test code, do this, instantiate this. If you have various different banking systems, for example, then you construct this object, so on and so forth. So try and make sure that your object instantiation and which one is not like a logic somewhere. Try and make it, you can use a reflection, Java proxies as well to help you with it. So there's this concept of cross-cutting concerns. So basically, when you're doing persistence and you're doing transactions, you will have the same so different objects will be implementing the same function, the same strategy, but the behavior will be, of course, distant. So like say persistence, file persistence, memory persistence, just talk about whatever persistence. They will be for the same functionality, same strategy. The behavior will be different, right? If it's a file system or something else. So there are in Java and in other languages as well, there's aspect-oriented programming. There is POCO or POJO, which is it's pure object. I don't know, is it pure object? I've forgotten what it's called. It's nothing but a basic class. Is it a pure object?
Plain Java object.
Plain, yeah. The plain object PLR. No, plain what? Or what does the O stand for again? Someone remind me.
Old.
Plain old Java
Plain
object.
old, yeah. So plain old CLR or plain old, C# object, and plain old Java object. Thank you guys. We've been just using it as POCO. So so it basically is nothing but just very basic objects. And the reason these names came into picture is because there is no fancy name for it. They just gave it a fancy name, but it's nothing but just basic. You go back to plain old, basic classes, and you respect, how you write classes. So you use so I mean, there are so many times where we've had to solve these problems using reflections. It's beautiful. So, for example, we even implemented using this sort of reflection, which is like in like Java proxies, to basically create different types of objects depending on the tags automatically coming into the data and keeping things. So because it's so generic, then you know, you don't have to write different bits to it. You could just say, hey, you know, considering it's like this, then just run this operation, be it this object, be it that object, it'll all work because you have the differences. If most of the things are the same, then whatever method, you know, the function that you've overwritten, it works. So reflection and Java proxies is really powerful in writing sort of a clean code. And test drive the system architecture. So think about how you would want to test your systems and yeah, test drive it, write test cases to make sure you're testing you're testing your system for various bits as well. And optimize decision making. So basically, like the POCO or the POJO is you know, it's just in time compilation, right? So basically, you haven't like created a you know, static. It's like a dynamic you know, instantiation of the object, and then you make just-in-time decisions of based on the dynamic instantiation what you want to do, rather than, you know, write a lot of static code. So you can write just you can minimize the amount of code you can write. And use standards wisely. So you may want to write a code for you know, in a standardized. So you see the same you know, you come up with it and you actually look at your code or what is required, and then you think, okay, this is actually a standard. Then you come up with standards, but then you have to remember that using standards have a long turnaround time. Of course, use standards where it's necessary, but remember that standards have a long turnaround time. By the time you updated the standards and actually, you know, get to implement, it's a long cycle. So try and avoid if you can, but if you need to, absolutely go for it. And also let me see, whoops. Also, then there you actually get some domain specific languages now, which you know, which basically solves so like, say for example, like in AWS, I'm just thinking of an example. If we have a SDK for like our DynamoDB, and there's already like domain specific languages which is related to the database, which you can like invoke, and gives you that level of you know, abstraction and not having to re-implement things from scratch. So use that wherever possible. So my question to you, have you used you know, any like Aspect J, Java proxies, reflections, whatever in your programming language, what it translates to? Have you used it, and what problems has it solved for you? Very, very quickly. Anyone? Yeah.
If you use Spring Boot, for example, or Spring Data, you use this by default. Spring already have AOP. In my company, we have our own framework to connect to database, and it's also used this concept of oriented aspect in programming. The disadvantage, well, we don't use annotations to reflect objects, which is like the disadvantage of Spring, for example. It's very hard to debug. It's very hard to understand what exactly has happened because always too many proxies. And we have our own framework without annotation, but it allows very easy to debug it, to understand what exactly was the object that proxied in your injection. And yeah, that's why we followed this way in the beginning.
Yeah, I haven't used Aspect J, but I've heard a great deal about Aspect J and how it solves the problem of via configs and how the cross-cutting concerns are like solved by Aspect J. It's got the best of both worlds, like POCO and AOP, aspect-oriented programming. Okay, anybody else before I move on? Okay, right. This one is interesting. This is getting clean via emergent design. So using design to actually make things clean. So basically, there are 4 rules. The first rule is run all tests. Yeah, so design for testability, have single responsibility functions, dependency inversion, like I said, and dependent injection for tight coupling. What you want to do is basically have low coupling and low cohesion in your design. So try and have tests for testing all of these, right? And make sure you run all these tests. Second, refactoring, because actually writing tests will also make sure that you have low coupling, means you're not put too many things together, and they are decoupled. And so yeah, again, test is a winner. The rules 2 to 4 is all about refactoring. So you don't, it is very, very important to actually carry on refactoring and making sure that the code is clean to satisfaction, make sure there's no duplication and the code is reused, and also express the intent of the programmer. So basically the design patterns are a way of even expressing your code. So using a design pattern, you're actually saying what you're trying to solve there by using a design pattern. And minimize the number of classes and methods, of course, by refactoring again. Just carry on, refactoring until you're happy. So one quick question, last question: what design patterns have you used to solve problems? Even anti-patterns are fine.
I can start. Well, actually, I think all creational patterns, like factory method, abstract factory, all these things that actually provided to create it. As I said, we use finite machine states, so with a state pattern. For one task, I used chain of responsibility, which were like almost in the place, because there was just logic to enrich files with a lot of logic. But I would say, like, if you build authorization, for example, for users, that's definitely the case for chain of responsibility, because you need always filters. And yeah, so actually several of them. Comment also very lawful to like create an abstraction before your methods, like to create all of them in commons. So that's one I used as well. And publisher and subscriber, I think it's like if you use queue, message queue, then you by default use publisher and subscriber. Yes, that's it.
Okay, anybody else? Sorry, my daughter is like hijacked the meeting. I don't know how much time I have, but there you go. So yeah, anybody else would like to talk about design patterns, or we'll quickly move on, because there is another topic about concurrency. I think this is the last topic and my favorite topic. Yeah, so usually when we implement, I try and avoid concurrency if it's not required, right? If there's no need for speed, there's no need for driving concurrency, then we don't use it in terms of code. You can always solve concurrency in different ways. But if you do need concurrency, there are times where for us, every like millisecond is very important, in which case we then implement concurrency. But if you are implementing concurrency, then you have, you have to guard against quite a lot of errors. The thing about concurrency is easy to like, you can just implement it, but it's difficult to test, and it's also hard to get it right. Because it depends on a plethora of things, and you can literally have another book club based on concurrency, because there's so much to it. But to keep it short, basically, how can you make sure that when you implement concurrency, you don't run into issues? Is make sure that your there's a single responsibility principle, that is, whatever your code is, keep the concurrency related, to that code, and separate different codes. So if you can separate different codes, and one that's doesn't need it, take it away, or if it needs it, it's doing its own thing. So just keep them as small as possible. Make sure that they are only doing what they are expected to do. The second thing is limit the scope of data. So if your scope of data is, if the data is encapsulated and there's no access to the thing, and you're sharing less data, that's great, because that means you need less critical sections. So try and keep that in mind, and try and keep these critical sections, down to like really small, because that's the problem. And the other bit is use copies of data to avoid synchronizing. So if you can, and your data sharing is involved, your data is the the limited resource here, then you can think about, hey, can I create a copy of this so someone else reads it, and you don't have to synchronize, keep the data synchronized. Can you make copies of this data? Rather than have critical sections and make it overcomplicated. This is something that you can think about. And then threads should be as independent as possible. Obviously, make sure that A is not requesting B, and is not waiting, B is not waiting on A, and to get into these sort of deadlocks. Make sure that independent threads do independent things, and there's even as far as on even different processors will be great. And then you can think about microservices and services oriented architecture in that sense. But if you're talking about threads, make sure that these as much as possible there's no interactions. Also know your library, which is very important, very underrated, but know your library. So I was using one of the C# Visual Studio libraries. This is like 10 years ago, and this was causing like race conditions, and then thereby after debugging, it was not really obvious because the code said it is thread safe. But I went and looked at the implementation that's available for that, and read up more about it, and realized that actually it is not really thread safe in certain scenarios. It basically doesn't work, which was the issue we were hitting as well. So know what your library is, whether it's thread safe, how to use it, what scenarios not to use it, so on and so forth. And also beware of the dependency between synchronized method, exactly, if there's a shared object, just be mindful you don't run into deadlocks, so on and so forth. Also think ahead about how to write correct shutdown code, because when all of this is in synchronization, and you want to implement concurrency, then you want to talk about shutdown. If something doesn't shut down and you're waiting with something, you're going to carry on waiting forever. So make sure that you've thought through it, and your shutdown logic is implemented early on, and get it working early on. And I can say that this was a Windows service that I was writing, and absolutely occasionally the shutdown would take so long that the service would actually terminate the thing when you stopped it. So we had to rewrite parts of this shutdown ourselves, and in different ways, but we solved it. But yeah, it is a challenge. Sometimes it's easy, but sometimes more often not, and when you're having concurrent stuff. So I'm gonna, because in the lack of time, I'm just gonna quickly move on to here as well. So one of the things that's interesting that I read from having this book is actually I always test for like scalability. I hadn't thought in terms of like testing for concurrency. Or somewhat you just do one or two, but you didn't go the full, the full hog and test for the specifically for concurrency. And this was a very good book in terms of like, hey, when you have concurrency, like you have async functions, testing is as important. Just like a few like calls here and there is not enough, and it's good. So the things I took away is run on different platforms. And we've noticed that if you build a DLL, it works on Windows, might work very differently on Linux, or might not even work on Linux. And, the behavior differs. And run more threads than processors. I mean, like I said, this topic of async is a different ball game. We can be here forever, but run with more threads and processors. And also make sure that your threads are tunable, how many threads you want to run. So you can, you can say, I want to run thread within my thread, 10 threads, I want to run all of this to make that tunable, which we had done for our multi-threaded Windows service. When we did it, make sure your threaded code is also pluggable, and get your. So when you write your code, make sure your non-threaded code is working first, right? The basic things, and then go and write your, plug in your threaded code and test it. And and also try and instrument your code. Like the aspect, for example, and CGlib, ASM in terms of thing. If you instrument your your code, and you can see what is really going on, what went where when you try to test it, so that instrumentation of the code will really help. But I think one takeaway for me is so we have like scalability tests that we run hugely, which tests which literally scales it. But apart from that, we don't do any more tests for concurrency, even though we have async code. So it's my biggest takeaway. So my question to you, to the audience, is, do you test concurrency in your company? And I would love to see which tools you use and how you do it.
Yeah, I put in the chat just in case if we will not have time. But I am happy to share that we just create executor service and run serial threads, and the code that you want to be concurrent, you execute in different threads. So you are sure that, for example, this variable was accessed only once, and all calculation was correct. So yeah, that's the trick. You create serial threads and tests. So even unit tests allow to test concurrency a bit, but yeah, it's possible.
Have you found issues by testing, for concurrency? Have you actually found it in your test, or have you found it in the production?
You mean the bug? I mean, I really can check that it's correct if I run these threads in tests in JUnit. So, and then we put it in production. no uncovered code in production.
Yeah, so today's latest, code issue that we had is basically we were spawning like 800, 1800 threads. And as long as you were the lower the thread, everything is working fine. But increasing to 1800 threads, the system is able to cope with the capacity. But funny enough, the data is that comes out of it, the device is not happy with, and you look at it, the data looks the same, but something is going on. Like I said, it's somewhere, it's something is going wrong, and it's all concurrency related. So
I think we definitely need more topics on it.
and it's a very interesting, I love concurrency, and that topic is you know, it's I just love it. I don't know why. Like usually know your execution models. Like when you're writing your code, and you're trying to solve the problem for concurrency, see what sort of a problem is it. Is it producer consumer? Like producing is happening, consuming is happening, then the bottleneck is a queue or wherever you're putting it, right? So you look at it in a different way. Readers, writers is where basically more reading and occasional writing. That's another problem to solve. And dining philosophers is the trickiest, because it's more like think about diners sitting on a table and they're doing mostly thinking, but occasionally come and then want to eat something from the table, and they will use a fork and another fork to say, hey, I want to eat it. Once they've eaten it, they put the fork back on the table, sides and forks, and yeah, that's another problem. So look at what you're trying to solve and what's the best way to solve it, because these things have standard ways of solving them. That's it. Is there anything else that you would like to share? Just openly, any questions, anything, any opinions, anything you'd like to share, feel free. The room is all yours.
I hope we will not be kicked off in 1 minute, because the Zoom only for 2 hours, but let's see. Like, if it will be kick off, just contact us in Slack and let us know if you need any workshop on the topics that we discussed. We will happy to organize them. And Hamda.
Hi. I just wanted to say thank you for being so engaging and giving such a great presentation. I feel like you've given me lots and lots of things to think about as I am in sort of the very beginnings of my career. Hopefully, as I learn more and more things, I'll keep coming back and implementing some of the stuff that you've spoken about. But yeah, I just wanted to say thank you.
Thank you so much. It means a lot to me. Thank you, Hamda. And I think we could have another session of like concurrency, maybe, if you're all interested. That's one of my favorite topic as well. Yeah. Any questions, anyone?
All I'm going to say, thank you so much, Rajani. I normally don't work with Java and C backend mostly. I'm usually with front end. So for me, it was just like, because I struggle with OOP so much, but it's just so interesting that it's something that I do want to sort of go into in the future. So thank you so much for all the information.
Thank you. I wanted to keep it language agnostic as much as possible, but it is a Java book, so okay, so we're getting some ideas for what they would like to know, I think, for Python and test-driven for machine learning. Thank you, Angel. Object-oriented patterns, yeah, that's another good idea. Thank you.
Yeah, thank you so much. Thank you, Rajani. It was an amazing presentation. It was a great job. Very cool. And yeah, again, contact us in Slack. Give us feedback, if you want anything else. And let's wait for the next book as well in the channel. And yeah, I was really happy to see you all in this evening for 2 hours and you're still here. That's amazing. So yeah, thank you so much and bye. Have a nice rest of the evening.
Yeah, thank you all. Thank you for being here. It's lovely to just hear about what you think, and yeah, what's going on in different organizations for me as well. Thank you. Thank you, Hamda, for coming up and sharing.
Sharing all of my mistakes, all of my bad code.
It's not there, right? Nobody is perfect. The journey.
Yeah. Thank Thanks everyone for listening to me talking so much. So, bye.
Bye bye.
Bye.